So if you notice, I don't answer the questions in order. I do the ones that I want to do first because I get kind of lazy sometimes. So number 3, it says if f of x equals x squared plus 3x plus 2 times x squared minus 4x plus 3 and g of x equals to x squared minus 9, then how many real solutions are there for the equation f of x equals g of x? This here looks really complicated. So I don't want to try to do this algebraically. I'm going to use my resource, which is my graphing calculator, and I'm going to clear this, and I want to enter f and g into my calculator. So for y1, let's enter in f of x the way we see it. So parentheses, x squared plus 3x plus 2, close parentheses, open a new set, x squared minus 4x plus 3, close that up. And then for y2, we're going to put g of x by using our down arrow. And that's going to be x squared minus 9. And what we're going to do is we're first going to look at the graph. So in this case, by analyzing the graph, the functions meet twice. They cross each other twice. So that means in this question, there are only 2 real solutions for the graphs, for the equation. Let's reset, hit second, go to graph to look at the table, and let's find out what values do they have in common with each other, if they do. If we can find it, maybe we can, maybe we can't. So they both have, at x equals 3, they're both 0. So that's one value. But based on this graph, I don't think you can find the other value because this gets really large. So let's just stick to the graph. There's only 2 values where they're equal to each other at. And there you go. So that's it for number 3. And basically, if it's a multiple choice question just like this, you can use the graphing calculator and look at the graphs to see where they intersect each other. But if it is a short answer question, like the one we have down here, then you must use algebra. But since I'm on that question, let's go to the multiple answer section and look at question number 2. It says, for the pair of polynomials given, select all the points of intersections of their graphs. So we're going to do the same thing. We're going to enter in g of x into the top one. So we're going to clear y1, clear y2, enter in g of x into the y1. So parentheses x plus 7 times x minus 5. And then for the pair on the bottom, that's just going to be x minus 5. And we should already know basically because they have a common factor here. By default, the pair of 5 zeros should be an answer. But do not pick negative 7 comma 0 either. That is going to be incorrect. You must use this to find out where they intersect with each other. So hit graph. I want to make the window a little bit smaller for y, so make that negative 10. Make the max positive 10. Maybe I should have reset the window. Let's make that actually negative 20 and make that max positive 20. 30 is fine. I don't care. All right. It's being difficult. So what you can do is you can hit second, go to table, well, second graph, look at the table, and find out which values of x has the same y values. So if you notice, at 5, 0, that works as well. These numbers gets too big over here, so I'm going to go the other direction, to the negative side. Oh, if you notice, at x equals -6, they both have the coordinates at -11. So that's also -6, -11. So by using the y equals function in your calculator and by looking at the table, you're trying to find at which values of x are the y's equal to each other. And there you go. At 5, 0, and at -6, -11. That is it for this video. Or so we thought. Because I'm deciding actually to do this one as well. So what you're going to do is, for short answer number 4, we're going to do the same thing, y or x squared. That's plus 8x, so delete, plus 8x minus 5. Then the other one is going to be 8x minus 4. Let's hit second and graph. Let's look at the table and see where they intersect with each other. No, let's go down a little bit. Let's see. Well, if you look here, at -12, so I want x, so here, right? In this case, x equals, I'm only trying to find the x values in this case, x equals -1. The y values are the same. And then notice here, when x equals +1, the y values are also the same. And that appears to be it. There's no other points of intersection based on what I'm seeing, because these values are both going up in the positive direction. And the first one is getting a lot larger than the second one. So by looking at the table, we found our values. But it says algebraically determine the values of x. So in the next video, we're going to do this by algebra. I'll catch you in the next one. Take care.